Hello everyone. Today let's solve the problem number 54, spiral matrix. So what the question states here, we are given an m into n matrix. We have to return all the elements in spiral order. So let's come to the example one here. So you can clearly see here they have shown this one clearly. So here first row we have 1 2 3, second row we have 4 5 6, and the third row we have 7 8 9. So here what we are doing, we have to move this one in the spiral order. Means this one first we have to go this way 1 2 3, and then we are going this way 3 6 9, and the third we are going this way, right, left. So 9 8 7, and the final we are going with 7 4 5 or 4 5. Here 4, third step, and the fifth step is inwards, nothing but the last element, that is center element 5, right. Three steps are there, 1 2 3 3 6 9 or 6 9. Here this one, 9 8 7 4 and 5, total 5 steps are there, sorry, right. So right, bottom, this one down, left, up, and finally right, right. So this is the thing that we need to do. Let's look at the second example as well. Just give me a second here. This one you can clearly see here, 1 2 3 4 8 12, second 11 12 9, 11, yeah, 12 11 10 9, and then 5, and then finally 5 6 7, right. So this is what we need to return as output, 1 2 3 4 8 12 11 10 9, finally 5 6 7, right. So I hope the question is completely clear. We have to return the matrix in the spiral order, right. So they have clearly mentioned, the question name itself is spiral matrix, you can clearly see here, right. So I hope the question is completely clear. What we need to do is completely clear. First what we will do, we will discuss the approach, followed by the this one, edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. So first we will discuss the approach. I'll just consider the same example so that it will be easier to understand. Example 1 that they have given in the question, right. So first let's discuss the approach step by step. First thing that we need to keep in mind here is we will be going with the spiral traversal, the approach spiral traversal, right. So I have considered the first example that they have given in the question, right. So here same thing, the output that we need to get here is 1 2 3 6 9, 6 9 8 7 4 and 5, right. We have already discussed this one. So the first question I'm considering that they have given in the question, let's discuss this one step by step. What we need to do here, we traverse the matrix in a spiral order. Just keep this in mind, we will traverse the matrix in the spiral order, moving right, down, left, up, iteratively until all the elements are visited. Next, after up, we will again move right if the elements are there, right. So middle elements or the last few elements that is formed, again we will be going right. So this we will be doing, we will be traversing the matrix in a spiral order, moving right, down, left, and up iteratively until all the elements are visited. So we will follow these steps until all the elements are visited. So let's see the step-by-step explanation. I have considered the same example, the first example that they have given in the question. Here, this was 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So we have to move first right, down, left, up, and finally we are moving right. That's what I said here. So if the elements are left, finally again we will move right. So the first here is 1, 2, 3, right? So this one. So let me consider this one. This one, 1 2 3, we will move right. So we got 1 2 3 here, top row, right. This, I hope this is clear. And the second one is we will move down, spiral traversing. So we have considered this one in the first step, we traverse the matrix in a spiral order, moving right, down, left, and up iteratively. This one just keep in mind, we are not doing it recursively, we are going with the iteration until all the elements are visited. Again I'm telling, we are going with we are doing this iteratively, we are not using recursion here, right. So first thing is 1 2 3, next we have to move down here. So this is 3 6 6 to 9, this one, right. So 6 and 9, 3 to 6 and 6 to 9, 6, 9, nothing but last column here. In this case, this is covered. Next, move left, 9 to 8 here, 8 to 7 here. This is nothing but 8, 7. This is bottom row reversed, right? Bottom row reversed. So final step here is move up. Move up means 4. 7 to 4 here. This one you can clearly see. Move up means this one 4, right? This is first column moving upwards. This one first column itself, right? This one 1 4 7 is first column. This is first column basically. This one I'm speaking of, right? Sorry, yeah, 1 4 7. So when we move up 7 to 4, we have already covered 1, so this one will be marked. So we will cover 4 here, right? So this is first column moving upwards. The final one, now remaining submatrix we have to cover here. In this case, we have to move, we are moving right, means only 5 is left in this case, right? You can clearly see here we have covered 1 2 3 6 9 8 7 4, then only 5 is left. Now what we will do, we will move right here. In this case, 5 is less, nothing but the last remaining element. So this is also covered now. So now we have covered 5 as well. Now the matrix is here 1 2 3. The order you can clearly see 1 2 3 6 9 8 7 4 and 5, right? 1 2 3 6 9 8 7 4 5. So here you can clearly see the final output here is 1 2 3 6 9 8 7 4 5. So this is the output matrix 1 2 3 6 9 8 7 4 5. You can clearly see here, right? This is the output that we got, which is equivalent to the output that they have given for the example 1. You can clearly see here 1 2 3 6 9 8 7 4 5. So 1 2 3 6 9 8 7 4 5. So the approach works absolutely correct. So this is the approach that we will be going with. This is the thought process basically. So this we have to articulate in the form of code, that we will see after discussing the edge cases, right? So this is simple. I hope this is completely clear, whatever we need to do and what is the approach and what is the thought process that we went with, right? So here you can clearly see this one. So again, this one, just this these 4 lines are very important. We are traversing the matrix in spiral order, nothing but we are going for the spiral traversal, right? Right down, left and up iteratively. This is very important while we articulate the same thought process in the form of code. So this is very important. We are doing it iteratively, not recursively, until all the elements are visited. Just keep this in mind. I hope the approach is completely clear. Now let's discuss the edge cases one by one. The first edge case we are going with here is single row. Here you can clearly see 1 2 3 and 4 are the elements that we have here in the input. So output that we will get here is 1 2 3 4 itself. So why here the output is 1 2 3 4? Because we have only one row here, right? So that will be 1 2 3 4 itself. So here we have single column, that is 1 2 3 4. So the output will be again here 1 2 3 4 itself, because we have the single column here. We will move down itself, right? So output will be 1 2 3 4 itself in this case as well. So the third one, the third edge case that we are going with here is 1 into 1 matrix. So here we have only one element. The output will be quite obviously 1 in this case, right? So the output will be 1 in this case. The fourth edge case here is rectangular matrix. So 1 2 3 4 5 6 we have. So output will be in this case 1 2 here, sorry, but this is the output matrix, right? Just give me a second here. This will be 1 2 4 6 and 5 and 3, sorry, 1 2 4 6 5 and 3 here. So this will be, yeah, so here this will be 1 2 3 4 5 6, right? So 1 2, first we will move right, then down, this one 5 6, this one, and finally up here this one. So this will be 1 2 4 6, this one you can clearly see here 1 2 4 6 5 and 3, right? So I hope this is clear. So this is for the edge case rectangular matrix. So the first edge case that we went with here is single row. The second edge case that we went with here is single column. The third edge case that we went with here is 1 into 1 matrix. The fourth edge case that we went with here is rectangular matrix. I hope all the edge cases are completely clear. So this is the approach, and these are the edge cases that we need to keep in mind. So I hope the approach as well as the edge cases that we discussed is completely clear. Now let's start writing the code. So now let's start writing the code. Initially, let's go with the initialization part. We will go with row begin, row end, column begin, column end. Also, we are storing the result in the another array, right? Or the resulting array. So you can just consider that one answer or result, right? So I'll just go with row begin. I'll just give your RB in this case. Let's initialize this one to 0. Row end. Let me go with here RE equals last element, that is nothing but length of the matrix minus 1. So the next step here is column begin, nothing but I'll just initialize this one to 0. This one is column end. Let me initialize this one to matrix of 0 dot length minus 1, and this one let's initialize the result variable to empty matrix. So this is fine. So here this is the first step. The next step here is we will loop until all the elements are visited, right? So here we can just call this one as loop continues until all the elements are visited. So this has to be true at any cost, right? So let's make use of the while loop here. RB less than or equal to row end and column begin less than or equal to column end. I hope this is completely clear. So the next step here is we will traverse from left to right, nothing but top row, right? So we will traverse from left to right initially, left to right, then bottom or this one down, then left, then this one, what do we call, up, and then if any elements are left, then right. So this one we know this from the approach. So first what we'll do, let's traverse from left to right. How can we articulate that one in the form of code? So for loop here, let C equals column begin C less than or equal to column end and C plus plus here. So this is fine. Result dot push of matrix of RB row begin and this one here is column. This is fine. Row begin plus plus. So here we are incrementing this one, right? So we have to move the top boundary down now. So now let's traverse from top to bottom. So first step was we were traversing from left to right, then we have to traverse from top to bottom, right? So again, so I'll just copy the same thing and make the necessary changes here. This one, sorry, this one here, let me copy this one. So here for top to bottom, this will be row equals row bottom, and here again row less than or equal to, this one has to be row end, this one has to be, we have to increment the row, right? Here result of push of row and a column end, right? So column end row, the last this one row and column end as well, the ending column. So the end column, top to bottom we are doing. So this is fine. So we have to increment the this one column end. We have to increment the column. Sorry, we have to decrement the column end here. So I got confused here. So this is fine. So the next step here is we have to traverse from right to left. So we traverse from left to right first, then top to bottom. Now we have to traverse from right to left, right? Nothing but bottom row. We are considering bottom row, right? Only if there is a valid row remaining. So simple if condition here, if row bottom is less than or equal to row end, then what we will do, for let C equals column end C less than, sorry, this is not C less than, C greater than or equal to column bottom here C minus minus. This is fine. So what we will do here, result dot push of matrix R E row and this one will be column. So this is fine. What we are doing here, we are traversing from right to left. We are considering the bottom row, right? Only if there is a valid row remaining. Just keep this in mind. So we are decrementing the row end here in this case. This is fine. So the next step here, what we will do, or what we have to do here, we have to traverse the bottom to top now. Again, if you remember the approach, left to right, top to bottom, right to left, and now again bottom to top, left column, right? Only if there is a valid column remaining. So again, so let me copy the same thing here and make the necessary changes here. So this one, leave one line gap here. So this one, instead of row bottom, this will be column bottom equals, this one will be column end, less than or equal to column end. So again, your for loop, in the for loop we are going for row less than or equal to row equals row end, we are initializing, row greater than or equal to row bottom. So this one has to be row. So this one has to be, we have to decrement the row. So result dot push of matrix of row and column end here, row and column end here. This is fine, I think. So we have to go with the column begin here, right? So let me format the code once. So now we have the code with us. So the last one here is, we have to return the final spiral matrix. We have to return the final spiral matrix. So let's return a result. We are making use of the resulting array right here, this one. So we are pushing to the result one itself. So finally we have to return the final spiral order of the matrix, or return the final spiral order. So let me format this one once and let me hit the run button. This is it for the code. I hope this works. Let's see. So here, what happened to this one? Wrong answer. What we are getting? 2, 3, 6, 9, 8 is fine. 7, what we have to get? 7, 4, 5, right? Instead of 7, 4, 5, we are getting 7, 5, undefined 4, 5. And 7, 4, 5, this one we have done something wrong. Means top, this one, bottom to top. So the last step we have done something wrong. Let's check what we have done wrong here. See here, in the line number 17, instead of matrix of row and column bottom, I have given column end here. So this one has to be, sorry, column begin. So this one has to be column begin. What we are doing in the line number 17, basically here, we are traversing from bottom to right, nothing but the left column, right? Only if there is a valid column remaining. So that is the reason we are going with a for loop, and we are pushing the result one. We have to push the result, this one, matrix of row, and we have to consider column begin here. In this case, this one I had made mistake. So let me format the code once and let me hit the run button again. Let's see. I hope this works now. Still the wrong answer. What we are getting here? Again, 7, 4 we are getting correctly. Undefined 4, 5 we are getting. Only we have to get 5 right here. Undefined and 4 we are getting. Where again we have done. Let's check the same thing here in the next line. Instead of this one column button, we have to increment here, right? We have to move right. After 7, 4, we have to move right. We are decrementing this one. That is the reason it is considering here undefined, this one 4 and 5. So undefined and 4 we are getting extra because we are decrementing instead of incrementing here. So let's go with, let's increment column begin here. So this one, let me format the code once and let me hit the run button. Now this has to work. Let's see. Yeah, now you can clearly see the sample test cases are getting passed here. So let me quickly hit the submit button. So here you can clearly see all the sample test cases are getting passed here. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is spiral traversal. We know this one, iterative spiral traversal, right? So you can clearly see here. iterative spiral traversal. Again, we are not going with the recursion. We have discussed this one earlier itself. So we went with iterative spiral traversal. So the overall time complexity would be, in this case, it would be big of m into n, right? So this would be big of m into n. And what would be the space complexity here? Overall space complexity would be here big of 1 in this case. So overall time complexity would be big of m into n, and overall space complexity would be big of 1 in this case, right? So why the time complexity here is big of m into n? Because we are visiting each element exactly once. You can clearly see here. We are visiting each element exactly once. That's what we have discussed, right? That's what we saw in the approach, right? So we are visiting each element exactly once, and that is the reason time complexity would be big of m into n, and the space complexity is big of 1 because we are using only a result array. Here you can clearly see we are making use of the result array that doesn't require extra space here, right? So we are making use of the result array excluding the input, right? So that is the reason overall space complexity here is big of 1, right? I hope this is completely clear, right? I hope the solution or the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.